And we live again. Today, this is a quick review and a recap to Lesson 17. Lesson 17 is solving equations with squares and cubes. For Lesson 16, we were going over perfect cubes and perfect squares. Here, we're going to be solving equations with squares and cubes. Also, we're going to be doing some work with variables and solving for variables as well. Our key questions is how many solutions does an equation in the form of x squared equal p have, and y, and then how many solutions does an equation in the form of x squared equal p have. X squared equal p, make sure you write that down somewhere. X cubed equals p, make sure you write that down somewhere. That is your square value and your cube value formulas from lesson 16. All they did was put a p on the end. That p is the resulting value after you squared or cubed the number. Okay, going to our fluency, which is aka our warm-up. It just says to evaluate each expression. It gives us some square values and then some cubed values. All we have to do is solve. I did number 1 and number 2 for you. Number 1 gives us 2 squared equals 4. The reason being, and write this down as you go. Reason being is because 2 times 2 is 4. You're not multiplying your base number to the exponent. The exponent, which is your order of magnitude, is just telling you how many 2's you need to have that you're multiplying together. And obviously it's 2 2's, but that makes a little more sense in number 2 when you're working with 2 cubed. So we're not multiplying 2 to 3 for number 2 because that's 6. That is incorrect. The proper process is to take 2 times 2 times 2, which equals 8. I'm going to leave you to do number 3, 4, 5, and 6 on your own. I will say don't be intimidated by 5 and 6. It's the same thing. The only difference is you're multiplying with fractions here. And if you can remember, when you multiply with fractions, you multiply the numerators with the numerators and the denominators with the denominators. I set up number 5 for you that has 1/4 squared. That means 1/4 multiplied to itself. You'll do 1 times 1, that's your numerator, and then do 4 times 4. That is your denominator. Okay? I might as well write the answer for you. That gives you 1/16. Do the same thing for number 3, 4, and 6. Come back when you're done. Here, it says for problems 1 through 4, determine the value that makes the equation true. And we're just going to do a little bit of practice from yesterday. Basically, is what this is. For number 1, it gives us 7 squared. 7 squared means 7 times 7. 7 times 7 is 49. That is our value. Done. Nothing more, nothing less. For number 2, it says same thing, but this time our 7 is negative. So it's negative 7 squared. And I'm going to just set up the work. Make sure you show your work. Negative 7 times negative 7 is a positive 49. Done. Okay. For number 3, it gives us 2 cubed. I'm going to set it up. 2 times 2 times 2. If you remember from yesterday, 2 cubed is 8. Now, if we did negative 2 cubed, you'll kind of get the same thing. But if you can remember from yesterday, because that 2 is negative and we are cubing the value, our result is going to be a negative 8. The reason being is because negative 2 times negative 2 would give us a positive 4. But when you multiply it that last time, that'll give you a negative 8 value. Negative 2 times negative 2. And you can use the multiplication signs or you can use the parentheses. It doesn't matter. They both mean the same thing. Okay? And we have negative 8. Also, I just want you to take note of the fact that when we cube a number, that the negative value and the positive value will give us the same answer from yesterday. So, for example, and we'll probably go over this in just a second. For number 1, it gives us 7 cubed equals 49. That is true. But if I also did negative 7 cubed, I would still get a positive 49. That's just something to note. Just something to be aware of when you have multiple answers for a cube value, and you will always have 2 answers if you ever need to break a number down. So that's if you started with 49 first, but let me not get too far ahead of myself. I don't want to confuse you guys. For number 5 through 7, it says determine all values that make the equation true. But if you notice, we are starting off with the end resulting number, or our p-value, better yet, should I say. Because the formula we're working with here is x squared equals to p. So here for number 5, we have x squared equals 16 is our p-value. And now we need to square root, meaning we need to perform the opposite operation to get the original number that we may have been working with. As I was just stating, that when you have a positive p-value, and you will always have a positive p-value when you are working with numbers that's been squared, it will always have 2 answers. So first, let's just square root. Okay, 16 square rooted, that gives me 4x equals 4. Why? Because 4 times 4 is 16. But if I did negative 4 times negative 4, or negative 4 squared, that will give me positive 16 as well. So here, when you're working with positive values that are perfect squares, like 16 is a perfect square, you will have 2 x values every time. It'll be a positive version and a negative version of the same number. That does not apply, though, when you're working with cubed values, like how we have for number 6 and number 7. Just off the top of my head, kind of like how what we were doing for lesson 16. Let me make my thickness a little more thick. There we go, that'll work. I know from yesterday, or the previous lesson, 16, that 3 times 3 times 3 is 27. So we know that the answer, if I cube root 27, the cube root of 27 is 3. Okay, that is our x value. And I'm just going to squeeze our formula here. X cubed equals p. Our x would be 3. Okay, but there's no such thing as saying negative 3 cubed is positive 27. That would not work. The reason being is because negative 3 times negative 3 would give us a positive 9, times negative 3 again would give us a negative 27 for number 7. Okay, so we can still cube root negative 27, but our answer will be negative. For this negative value, our answer will be positive for this positive value. So it's the same answer, but there's not 2 of them. Negative 3 cubed would not give you positive 27. Positive 3 cubed would not give you negative 27. Cubed values, or perfect cube values, will only have 1 resulting x value when you cube root them. Okay? Perfect squares have 2 answers. Perfect cubes have 1 answer. Note that somewhere. Moving on. We have a few examples here. I'm not going to do all of them. I'll just do a few and then we'll move on. It says for problems 8 through 14, solve for the equation. Here's our formula right here. X squared equals p. And we are solving for the x values, or for the variables in the equations. The variables don't matter. You just need to know that that's the value that we're looking for. Now we have x squared equals 100. So I know I need to square root 100. I know that 10 times 10 is 100. So x will equal 10. Okay, not 10 squared, just x equals 10. The reason being is because the square value is already in the equation, so we don't need to rewrite it. Just 10. Same thing here for number 9. All they did was write it backwards. It has 25 equals m cubed. We need to know what is the value of m. So we're going to square root, and we know that we need to square root just because this square value is there. I know off the top of my head that the square root of 25 is 5. So m equals 5. If you ever need to verify or solve, depending on how large the number is, you can just plug the same thing into your calculator. You'll get the exact same answer. That's how we solve those. I will leave you to do number 10 and 11 on your own. I would hope that for number 10, you know that 1 times 1 is always 1. I would hope that for 13, you know that 0 times 0 is always 0. For number 12, I'll knock that one out for you. Don't be intimidated by these large numbers, okay? Just because it's large doesn't mean anything. Now, me, I know that if I square root 225, I know that it's 15. But that's just because I've been doing this longer. I know that 15 is our n value. But if you're ever skeptical or you just need some validation or you're not sure, just plug it into the calculator. Okay? Just plug it into the calculator. That is our square root sign right there. We're going to put in 225 equals 15. Done. You're not going to have any crazy answers for this. This is very simple. We're just breaking numbers back down. All right. There we go. Put a star by number 14. It gives us w squared equals -4. And we're looking for the value of w. I know that if I'm trying to get to 4, I would either need to use +2 or -2 just because the square root of 4 is 2, but it's not a +4 in the equation. It's a -4. And +2 times +2 is +4. If I do -2 times -2, that'll still give me +4. So in this case, number 14 has no solution. That is a trick question there. It is a trick question because your perfect square values would never be negative, ever, ever, ever. If you ever see a negative value posted up as a perfect square, just know it has no solution every time. Here we're doing the same thing, except for now we're working with cube roots and cubed values. And I'm just going to do a couple of these for you. For number 15, it gives us x cubed equals 27. Now, if I perform a cube root, not a square root, we're working with cubed values now. If I perform a cube root, I know that I will get 3 because 3 times 3 times 3 equals 27. So our x is 3. Okay, because x cubed is 27. Done. Nothing more, nothing less. Same thing here for 16. It says 8 equals a cubed. We need to find out what the a value is. So what number cubed will give us 8? I know that 2 times 2 times 2 equals 8. That means 2 cubed will give us 8. So our a value is 2. That is our missing variable. Done. That's all we're doing. I'm going to leave you to do some of these on your own. I will do number 20 for you, though. Put a star by number 20. Number 20 gives us h cubed equals -8. And we need to figure out what number multiplied to itself a total number of 3 times will give us -8. I know from number 16, which is what we just did, 2 cubed will give me +8. But this answer is negative. So then the idea becomes, will -2 give me a -8? I know that negative 2 times negative 2 will give me negative 4. If I multiply it by negative 2 one more times, did I say negative 4? Excuse me. Negative 2 times negative 2 is positive 4. If I multiply by that third negative 2 one more time, that will give me negative 8. So H, in this case, is negative 2. That's how you do that. Anytime you have a negative perfect cube value, your variable value will be negative as well. For 15 through 20, we're doing the same thing, except for now we're doing it with rational numbers. All you should think of when you see something about rational numbers is partial numbers. Partial numbers. Partial numbers meaning decimals and fractions and things. Negative numbers, so on and so forth. I'll do a couple of these. I won't do a lot. For 21, it gives us x squared equals 4 over 25. Because this is a squared value, I know that I'm going to need to square root both of these numbers individually to get the resulting x value. If I square root 4, I know that 2 times 2 is 4. So my square root is 2. My square rooted value will be 2. If I square root 25, that'll give me 5. Why? Because 5 times 5 is 25. So x equals 2 over 5. Done. Okay. Let's scroll a little bit. Let's do, you know what, let's do 23, because 23 is actually pretty similar to a question from lesson 16 exit ticket. It gives us a cubed equals 1 over 64. I know I have to cube root, not square root, but cube root these values just because a is a cubed number. 1 times 1 times 1 is always going to be 1, so our numerator really doesn't matter. We know it's going to be 1. For 64 cube rooted, I have to figure out what number multiplied to itself a total number of 3 times will give me 64. We've been doing a lot of practice here, so I know that 4 times 4 times 4, or 4 cubed, better yet, will give me 64. So cube rooted 64 is 4. So our A is 1 over 4. Just like that. Done. Let me see. Might do one more. Let's do 26 together, because I want to show you how to put this in a calculator. 26 gives us b cubed equals 0.001. Do not be intimidated by these decimal numbers, whether they're really small, really large, or whatever. Worst case scenario, once again, just put it in the calculator. There's our cube root symbol. We have 0.001. That gives us 0.1. Done. So b equals 0.1. And that's it. And here, I'll put my cube root symbol there just so you know what we did. So every number can essentially be broken down for the most part. Don't be intimidated by these different types of numbers just because they're not perfect cubes or perfect squares. We have our exit ticket for lesson 17. It says for problems 1 through 4, just solve the equations. You are solving for the variables. Okay? I would say in advance, just pay special attention to whether if a number is squared or is being cubed, because that would tell you if you need to square root or cube root. Make sure you complete all 4 questions. You do not need an explanation, but you do need to show your work a little bit. Showing your work just looks like you setting up the equation as a cube root or a square root. That's it. When you're done, turn this in.